All right, let's do some cases on time value of money concepts. As always, as we work through these, I encourage you to do it in one of two ways. Either pause the video, work one exercise, one case, and then come back and watch it. Or if you choose, work them all and then come back and watch it. But each time, please work it before you watch the solution. Good luck. All right, welcome back. Hope that you had luck and, or better yet, just have the skill. Okay, so the first question is, what is the future value of $10,000 with interest compounded annually at a 10% interest rate for 40 years? Okay, so, and by the way, what we're going to do here, and I'll cover this up because I'll do it both using the financial calculator. I'll do it first with the tables, then the financial calculator, and then Excel. All right. So the future value, what's known here is the present value and the rate and the term. So the future value unknown is the present value of 10,000 times the future value table factor, future value of a sum, table factor for n equals 40 and I equals 10%. If you look at the table, you saw the answer there, but let's show you how that got there. Okay, so the 10% column is the third from the end. And now I'm going to put the ruler on the 40-year row, scan down, and that doesn't look very good. So let me bring the paper up. And the number, the table factor, is 45.25926. All right. There's 25926. And when we multiply the $10,000 present value, that's what we have invested today, for 40 years, it'll grow to be $452,592.60 in 40 years if our investments yield 10%. If we were doing that on the financial calculator, this would be the keystrokes. You'd put in 10,000 and then say that's the present value. 40 is the N, number of years. 10 is the I per Y, interest rate per year. And compute the future value. Finally, using Excel, so add this to your notes out there as well. The answer again is 452, 592, 56. And then those little rounding errors are because Excel doesn't have to round very much. So these are more precise. And then there's the keystrokes I put in the cell. Future equal future value. 10% is the rate. 40 is the number of periods. 0 is the payment. There is no payment. There's just the present value is negative 10,000 today, a $10,000 outflow. Don't worry too much about the negative. If you put in positive, it would just return this as a negative, but you know what it means. That 10,000 will grow to be 452, 592, 56. All right. And that is the first case. Again, if that doesn't make sense, please go back to the book and read a little bit about future value of a sum problems and watch the general video again and then work the problem. Let's go to number 2. Number 2 was a 0 coupon bond that has a maturity value of $100,000. Zero coupon bond means that it bears $0 interest payments. So you get your interest, you get compensated for them using your 100,000 by not having to give them 100,000 today. This bond matures in 5 years. What is the maximum that should be paid for this bond if you, the investor, require an annual rate of return of 8%? Okay, in other words, what would you buy this bond for and it would allow you to yield 8%? All right. And so this is you think about, okay, what's known? Well, known here is the future value, 100,000. And then we know that we want the table factor for 5 years, n equal 5, and a rate of 8% yield. So the future value is known, 100,000, and the table factor for 5 years present value of a sum for 5 years and 8% is 0.68058. And so you're willing to pay $68,058 for this bond. It'd be great if we could even pay less, and then we'll yield more than 8%. But if we require an annual rate of return of 8%, we're telling our bond bidder, walk away after if you bid $68,058 and somebody else bids more, let them have it. So here is the keystrokes if you're using a financial calculator. 100,000, future value, 5N, 8I per Y, compute present value. If you were doing that in Excel, there's that answer again. Equals present value. So this is the present value function. Rate, number of periods. Payment is 0. There is no periodic interest payments. And then 100,000 is the future value. That's the present value function, and that'll return 68,058.32. Notice I'm not putting a value in for type. The type value is only going to be required when there is a payment. It refers to the payment. So you don't need to put a type in. It'll take it, but you don't need to. All right, moving on. Again, if you've struggled with the present value of a sum, review that reading and that part of a lecture, and then work the problem again, work other problems. All right, question number 3, case number 3. You want to have $1 million in 40 years, don't we all? You believe your investment mix will yield an average rate of 10% each year. What amount must you invest today? All right, so we have a known future value. We have a known time period, N, and we have a known interest rate, R, or I. So our calculation is the present value is equal to that future value, $1 million, multiplied by the table factor. for the present value of a sum for 40 years at 10%. Okay, once again, we go to the present value of a sum table, and we know this 10% is the third last column. So let's follow our eyes down to the 40% row, and that third column is 0.02209. And therefore, you want $1 million, and if you're 22 years old, you want $1 million when you're my age, 62. Put $22,090 away in an investment account and invest it and earn 10%, and you'll be there. Using the financial calculator, you would do this way. $1 million is the future value, known future value, the known number of years, the assumed, quote, known interest rate per year, and then compute the present value. Obviously, if you are wrong on 10%, you get 9%. It's going to be something slightly less than $1 million in the end, but you'll do quite well. And of course, you can calculate all that. Let's see what this looks like on Excel. All right, this is the equals present value function again. I typed in, of course, these quotes, they're just there so that it would print the verbiage for me. Those quotes aren't in the cell. What's in the cell is equal PV, present value function, rate 10%, number of periods 40, periodic payment 0, and future value $1 million. All right. You can see there was a little bit of a rounding difference of $4, but I think you'll be happy with whatever the answer is. That's just, again, that's a rounded 5 digits, and Excel didn't round. Case number 4. You want to have $1 million in 40 years. You believe your investment mix will yield an average rate of 10%? What amount would you have to invest annually? So nothing down today, just an annual payment in. So think of this as like your IRA, your individual retirement account. Take it from me, it works. I started putting money in my retirement account when I was just graduated with my accounting degree in 1985, and that performed quite well for me. And I didn't miss the $2,000 a year. I used $2,000 because that was I could get a tax benefit for making a contribution into my individual retirement account. Okay, so here we have a known future value we want of $1 million equals a payment. We don't know what that is. That's the unknown multiplied by the table factor for future value of an ordinary annuity, 40 years, 10%. Do a little bit of algebra on that. Divide each side by the future value of an ordinary annuity, and you get future value divided by future value of ordinary annuity for n equals 40 and I equals 10% equals the payment. So future value is 1 million. The future value of an ordinary annuity table factor, well, we need to look that up, don't we? Right, so let's go to and let's find our future value of an ordinary annuity table. And once again, we'll go to the third to the last column. And we will bring our ruler down to 40. And there it is, the value. The value is 442.59256. All right, make sure you can find that. And that means that when you divide that out, it tells you that if you make a $2,259.41 contribution into an account every year for 40 years, at the end of that 40-year period, you'll have $1 million, assuming, again, you yielded 10%. Yield more, you'll have more than $1 million. Yield less, you'll have a little less than $1 million, but you'll be quite happy. Here's that calculation on a financial calculator. $1 million is the future value. 40 is N. 10 I per Y. Interest rate per year. Compute. Payment. Pretty easy in Excel. We use the payment function. Again, don't type those quotes in. There's the answer. Equals payment, 10%, 40 years. 0 is the present value. That's PV. We have nothing right now, but the future value is $1 million. And again, these inputs are all, you're prompted for them within Excel. So check it out if you haven't. That's the rate, number of periods, the present value, and the future value. We got 0 today, but we're going to have $1 million in 40 years. And we're going to do so by making a $2,259.41 payment into our account every year as we work. All right. Let's do a couple more. Okay, now let's see one that has both a bond that has both interest and principal. You're going to bid on a bond. That bond has a $100,000 face value, matures in 5 years, and pays an annual interest payment of $5,000. So it's yielding 5% interest at the end of each year. Based on the risk profile of the company, though, you desire a rate of return of your investment of 10%. In other words, we're not going to pay quite $100,000 for this because it's not yielding enough interest to compensate us for our risk. What's the maximum amount you will bid for the bond? All right. So on this one, we have to do it in a couple of steps. We have to get the present value of the principal and the present value of the interest, each of which we've already learned how to do. So we know the principal, it's $100,000, and we want the present value of that for 5 years, discounted at 10%. That table factor, 5 years, 10%. Is 0.62092. The interest is $5,000 per year, and it's an ordinary annuity of 5 years and 10%. So we need the present value of an ordinary annuity table factor for 5 years at 10%. And it's right there, 3.79079. And so that value is, when you multiply 5,000 times 3.79079, you get $18,953.95. So What this is saying is, and now let's come back to that calculator inputs. What this is saying is, I'm willing to pay $62,092 for the $100,000 payment this bond makes at the end of its life, and I'm willing to pay $18,953.95 for the five $5,000 interest payments over the life of it. So there's $25,000 of interest payments over the life. We'll pay $18,953.95 for those. Well, the bond pays both, so we're willing to pay the present value of the interest, $62,092, plus the present value. This present value of the principal, $62,092, plus the present value of the interest, $18,953.95. I'm willing to pay $81,045.95 for this bond. If I do so, it'll yield a 10% return on investment. Right. To use the financial calculator, you would say 10,000 is the future value, 5,000 is the payment, 5N, 10I per Y, compute present value, and you'll get that same value. And then it's pretty easy to do this in Excel. Present value function equals present value rate 0.1, 10%, N, number of periods, 5, payment, there's our first payment, 5,000, future value, 100,000, and then type 0 for ordinary annuity. The interest payments are occurring at the end of each period. And that'll return the correct value. And again, what this means is that if we're bidding on this bond, we'll bid all the way up to 81,046.07. If somebody wants to go up to 82,000 or even 81,100, we're going to give it to them. We're going to allow them to make the investment. We'll find a different investment option. Number 6. Here's a fun one. You won the bond auction not at a price of $81,045.95, which we are actually willing to pay. Don't tell anybody. We bid $78,000 and nobody outbid us. So what will be our yield to maturity on this bond? Well, I can tell you one thing. It's going to be greater than 10% because we would have yielded 10% at $81,045.95. Let's see what it actually is. All right. So this is one where you can do this with the tables, but it's not easy. So I wrote you a little note, and then we'll use the technologies for this one. The note I wrote is you could complete this problem using a TVM tables via imputing R. So give it a try for fun. You'll see what you have to do a relationship between the values. We'll try it in class. But it's very easy to do with technology. With the financial calculator, minus 78,000 is the present value, what we paid today. It's an outflow. 100,000 positive is what will be the fair value of our inflow. We will also get a $5,000 payment for 5 years, 5N. Compute the I per Y. And that IRR, or yield rate, is 10.94419%. Here's how I would do that in Excel. Equals rate, it's the rate function. 5N, $5,000 payment, $78,000 present value outflow. Future value inflow is 100,000. The type is ordinary annuity, 0. And then what's this thing? Well, this thing, and you're prompted for it. This says, hey, user, give me a guess. Because there's actually, if you're a good, really solid mathematician, you'll know that there's actually 2 answers to such a function. So it says, so I put in 10% because I knew it was about that. It's a little more than 10%, but I put in 10%. And what that says to Excel is, okay, there's 2 solutions to this. I'll take the one that's close to 10% because the other solution is quite different than 10%. And that's how to do those cases. Right? Thank you for your hard work. Give that practice. You're going to use that a lot in your schoolwork and in your professional career. So get very, very solid. And again, make them make fun. They're fun. They're fun problems. Indeed, I like figuring out how to do this kind of thing with the tables, but it's not necessary in 2024 to say the least. Still fun. All right. Now, the next few pages have similar, the next page has some similar problems that are a little more elegant. The first one says, you are saving for retirement. You place $2,000 in an IRA and get a nice tax benefit. The IRA investment pays 10% annual return on investment. How much will this $2,000 grow to in year 1, year 2, by year 2, by the end of year 10, and by the end of year 40? The end of 1 year is $2,200. Now, this is not an annuity, by the way. This is just that $2,000. It'll grow to $2,420 in 2 years, so it will have earned you $420 of interest compounded. By the end of 10 years, it'll be $5,187.48. By the end of 40 years, that $2,000 alone will have grown to $90,518.52. Okay, so just for practice, make sure you can get all those check figures. Let's look at another one. On January 1, 2023, Genesis Corp. got a loan from Wood and Houston Bank. Under the terms of the loan, Genesis Corp. will pay 0% interest annually in 23, 24, and 25, and then must pay $10,000 at the maturity date, which is December 31, 2025. If the loan was priced to yield 10%, how much did Generis Corp. receive at January 1, 2023? If it was priced by the bank to yield 10%. And then I ask another question. The loan will be reported at the present value of future cash flows under the loan's terms on the balance sheet. At what amount will Genesis Corp. report the loan as a liability on its balance sheet? And will the bank report the loan as an asset on its balance sheet at December 31, 23, and then 24? Okay. And so the check figures are 7513.15 for the present value at the date of inception, and then 8264.46 and 9,090.91. And then of course at the end, this is at the end of 24. This is at the end of 2023. This is at the beginning of 2023. And then, of course, at the end of 2025, the present value will be 10,000, but that's the day we have to pay it back. Okay, so take a second. That's just a little more practice for you. More practice on present values of sums. All right. In the next video, we'll do more elegant present value and future value of annuity questions. I gave you some check figures there as well, so please do those. All right. And thank you for your attention. Have a great day.